A grandfather clock uses a pendulum to keep time. How long would the pendulum need to be in order to create a period of exactly 1.0 seconds? So in this case, I'm given a period, which is a little backwards to most of the math in this problem set. I know that the acceleration due to gravity is 9.8 meters per second squared. And in this case, I want to know what a length is. I'm going to use the same equation, 2 pi, the pendulum equation, square root of L over G. So okay, let's replace numbers for letters. I know that 1.0 for period equals 2 pi times the square root of L over 9.8. Now, here's the thing. L is on the right-hand side, and it's got the square root on it. So I'm going to need to get rid of the square root before I solve for L. In the beginning, let's get the 2 pi over onto the left side. So I'm going to divide the right side by 2 pi, and that cancels. But whatever I do to the right, I got to do the left as well. And so then when I do this math, I'm a little bit simpler. I get a number 0.1591155, and that quantity equals the square root of L divided by 9.8. Now I want to get rid of that square root, so I'm going to do something sneaky. I am going to square it, which is the opposite of square rooting. Whatever I do to the right, I got to do to the left as well. And that gives me a number 0.0253330 equals L over 9.8. In order to get L all by itself on the right-hand side, I'm going to multiply it by 9.8. And this allows me to cancel. But whatever I do to the right, I got to do to the left as well. So I get that L equals 0.258237 meters. So I get that L is 0.248237 meters. So 0.25 meters.